So here's where we're at on the book. And I know, like I said, you weren't here, but this is the second time they're going to hear it. But all these lights meant that the electrons were in certain locations. So what is the main location of an electron? What do you call it? What do you call these rows? What do you call these really long rows? What's that called on the periodic table? Everybody? Periods. So the periods go like this. Groups and families go like this. So in period number 1, we only see 2 elements. Now, if I were to ask you, and you would impress me, if I ask you, why are there only 2 elements in period 1? Who wants to take a chance on that? Just raise your hand and say, I think I'll take a chance. Why are there only 2 elements in period 1? See, if I can get you... All right, Sierra, go. Very, very good. Thank you. I'm impressed. The first energy level, and the reason there's 7 periods in the periodic table is because we believe there's 1 energy level, there's 2, there's 3, there's 4, there's 5, and we think there are only 7 energy levels. But you are correct. Within energy level 1, we find these places. They're called probability zones. They're called orbitals. Orbitals are where you find electrons. And an orbital can only hold, you're right, 2 electrons at the most. So if we take a look, if you were hydrogen, every atom of hydrogen, say, what's the electron configuration for hydrogen's one and only electron? And it only has 1. Calcium has 20 electrons. Cesium has 55 electrons. So what is the configuration of the 1 electron that hydrogen has? In energy level 1, in an s orbital, you'll find 1 electron. So say 1s1. Now every atom of helium has 2. Now, can you put 2 electrons in the same orbital? And the answer is yes. Every orbital can only hold 2 electrons at the most. So if you say, what's the electron configuration for the electrons for hydrogen, helium? Helium has 2. You say in the first energy level, in the s orbital, there are 2. And so 1s2. Now, everybody from now on who has more than 2 electrons, they're going to put the first 2 1s2. They're going to put the first 2 electrons in 1s2. But if you look at the diagram, it says that energy level 1 only has 1 orbital. It's an s orbital, and that's it. That's why you can't put more than 2 elements in the first period, because these are the only elements that put all their electrons in 1 energy level, the first one. The first element to need. Who's the first element to need a second energy level? It's called lithium. That's why he's the first element in the second period. It's beautiful if you look at it. So let's take a look at lithium's electron configuration. You got 3 electrons. What are you going to do with the first 2? Same thing helium did. 1s2. What are you going to do with your third one? Can I put it in the first energy level? No. There's no more place. Can I go? I got to go to the second level? Yeah. But where do I go in the second energy level? There's an s orbital waiting for you. Not 1s, but 2s. Every energy level has an s orbital waiting for you. Okay. So now, lithium is 1s2, 2s1. Take a look. 2 plus 1, 3 electrons. The 3 electrons are the superscript. See that? 2 electrons are in the 1s orbital. 1 electron is in the 2s orbital. Are you with me? Everybody okay? I'm just reviewing. We're going to jump a little faster here. Now, can you put 2 in the 2s orbital? Yeah. So beryllium is 1s2, 2s2. There's 4 electrons. Now, something strange happens. Whoever has 5 electrons, something's going to look different to you. Now, over here in the book, I'll show you a page, very, very important. I'll write it here. They call group 1 and 2. Group 1, we don't have their own individual names, the alkaline metals, alkaline earth, we have that, but this right here, this whole thing here is called the S block. Now what that means is that if you're found that part of the periodic table, get out of here. If you're found in that part of the periodic table, you're either putting one electron in an s orbital, or two. For example, this is 1s1, and this has 2s1, and 3s1, and 4s1, 5s1, 6s1, 7s1, and that's why there's a Roman numeral right there. How many electrons are in your outermost energy level? So that's going to be a fancy word. The electrons in your outermost energy level are called valence electrons. Now, let's take a look at this, all right? Beryllium has a total of 5 electrons. 2 of them are in the 1s orbital, 2 of them in the 2s orbital, but you say, well, you can't put any more in an s orbital, you can only put 2. But guess what else is in the second energy level? A p orbital, a different shape, like a dumbbell shape, and another p orbital, and another one. So now, you could put 2 here, you could put 2 here, you could put 2 here. So how many is that? How many orbitals are in the second energy level? How many orbitals are in the second energy level? Hey, can you put that up, please? How many orbitals are in the second energy level? Isabella? 1, 2, 3, what? How many?
6.
How many? 4. Yes, so there are 4 orbitals in the second energy level, and each orbital can hold how many? Kyle, how many? Each orbital can hold how many? 2. What's 2 times 4? What's 2 times 4? 8. Now watch. In the second energy level, how many elements do you see? 1, 2, 3, 4, 5, 6, 7, 8. You understand this? There are 8 elements in the second level because you can put either 1 electron, 2, you can put 8 electrons in the second energy level. Yes, no. Now, it gets even better because the first two you put in any level go into S. Ready? 2s1, 2s2. 3s1, 3s2. Let's go down here. 6s1, 6s2. That's why it's called the S block. You're either putting 1 electron in the S or you're putting 2. And that's why it's called the S block. Now let's go over here, and there's a name for this one. What is the name for this part of the periodic table? And it's called the P block. Okay? Now, this is where it really gets good if you're willing to look for it. We know there were 2 columns in the S block because you can put 1 electron in S or 2. How many columns are in the P block? Watch. 1, 2, 3, 4, 5, 6. Look up here. Look right there. Why would there be 6? Because, see, 2, 4, 6. You can put 6 electrons in the p orbitals. And so you can actually read the periodic table. You say, I can't believe you can read the periodic table. For example, if this is 2s1, this is 2s2. Now we jump to block here, that's called 2p. I'm in the p block now. 2p1, p2, p3, p4, p5, p6. Now, the word valence electrons, I'll show you what that means. Do you see this guy here called boron? These are in the first energy level, and this is second energy level. Valence electrons are the ones in the outermost energy level. So if I looked at here, how many valence electrons does he have? And valence electrons, you say, why do you even want me to know that? Because in chemistry, it's the valence electrons that are involved in making compounds and making bonds. These are called core electrons. Core electrons are the ones that are not involved, they're not valence electrons. And here's what's really neat about the periodic table. How many valence electrons does boron have? I got 2 here, and I have 1 here. Now, watch out here. Look at boron. What Roman numeral do you see right above boron? 3. That means I have 5 electrons, but how many of them are valence electrons? 3. Are you with me? Let's go down here. Ready? Here's beryllium. He has 4 electrons, but how many are valence? Look at the Roman numeral. 2 of the 4 are valence. Right there. Outermost energy level. Let's jump down to fluorine. Look at fluorine. Fluorine has 9 electrons, but how many are outermost energy level? 7. 7 valence electrons. And what Roman numeral do you see right above fluorine? What Roman numeral is above fluorine? 7. Yes? Okay, now, what you're going to find is that there's magic number. There's a magic number in chemistry, and it's 8. And what's going to happen here is, okay, when you put 2 in the S and 6 in the P, you have 8 valence electrons. Now, that's special. Matter of fact, you're so special, you have your own column. Except for helium, it only has 2. I have 8 in my outermost energy level, 8, 8, 8, 8. And here's the irony, okay? You guys know what irony is? Okay, here's the irony of this. You know, hey, why do you want to lose electrons? Why do you want to gain electrons? Why does everybody want to do chemistry? The secret to find out why elements wanted to react came from this special group of elements that don't want to react. When we found out what elements don't want to react, we had to figure that out. Why don't you want to react? For example, if you put 2 in the S and 6 in the P, if you give me 8 in my outermost energy level, give me 8, I don't want to do anything else. Hey, do you want to gain electrons now? No. You want to lose? No. You want to share? No. That's why these are called the noble gases, all called the inert gases. They don't like to react at all. There's no chemistry, almost no chemistry there. But I want you to think about this. All right? This is the hardest thing I'm going to say all day. Look at fluorine. Fluorine has 7 valence electrons, right? If it had one more, it would stop reacting, wouldn't it? Again, here's the hardest thing I'm going to say all day. Ready? When you were writing compounds, what did I always say? What do you always put fluorine? What charge does fluorine have in a compound? What did I say? -1, wouldn't it? A -1 doesn't mean you lost something. -1 means you have an extra negative electron, doesn't it? So what does fluorine want to do? Fluorine's sitting there with 7 electrons, but if it had 8, it would be very, very stable. So what does fluorine want to do? Give me 1. I'm going to steal 1 from somebody, and then I'll have 8. And let me show you how this works. Everybody in this column has 7 valence electrons. That's why all of them would love to gain 1 more, so their electrons would be just like these guys' electrons. Look at this column here. How far away from 8 are you? I got 6 valence electrons. How far away from 8 are you? 2. They tend to gain 2 electrons and become -2. 5 valence electrons. How many would it take to make 8? 3 more. Everybody in this column has a -3 charge in a compound because it was to gain 3 negative electrons. Now, if the magic number is 8, what's halfway of 8? What's halfway to 8? 4. So if you're in column 4, you sometimes gain and you sometimes lose. Uh-oh. That was weird. It's never done that before. Huh. Oh, right in the middle of mine. All right, try it again. So one more time. What's halfway to 8? 4. So let's think about this. If you're more than halfway to 8, no wonder you're called a nonmetal, because you want nonmetals like to gain electrons to get to 8. But look at this guy here. Look at sodium. He has 1 valence electron. It's going to be very difficult to gain 7. But you know what would be easy for sodium to do? Lose 1. If he lost 1, he'd have 10 electrons, and his electrons would be like neon's electrons. And that's why these guys always form +1 ions, because they want to lose a negative electron. Now I'm trying to link a chapter we had with writing compounds with this modern atomic theory. All right, let's go on with this. Let's see if we can go ahead and finish these, the first 20 elements. What's the next element? Let's see, who's ready today? Is everybody ready? Dan, you're ready. Dan, what's number 13?
13 is
Okay, so every atom of aluminum has 13 electrons. Where are you going to park them?
It would be 1s2.
So 2 of them go in the first energy level in s orbital.
2s2.
Okay.
2p6.
Okay.
And then 3s2.
3s what?
2.
2. Okay. Let's count them up. 4, 5, 6.
And then
Oh.
3p1.
What now?
3p1.
Ah. Now, if you count them up, that's 13, isn't it? Now, I want to show you something. You might be sitting there saying, you want me to memorize these? You want me to memorize all? No, I don't memorize any of these. I look at the periodic table and I read it. Let's read it. Ready? I'm going to go left to right. 1s1, 1s2. Now, this is called the S block. 2s1, 2s2. Go to the P block. 2p1, 2p2, 2p3, 2p4, 2p5, 2p6. Are you with me? Third energy level. You always start with S. 3s1, 3s2, 3p1. That's how I knew you should have ended up at 3p1. Everybody in this column is a p1, p2, p3, p4, p5, p6. Read it. You read the periodic table. You don't memorize it. All right, so the next one. Madison, what's the next element? What is it? Oh, silicon, yeah. Okay, silicon, go. We're going to do 14 electrons. And is silicon in the second P column? Is it or not? Oh, yes. She should have ended at 3, P1, P2. She should have ended with 3, P2. All right. Either one of you weren't here yesterday, but boy, you would impress everybody. If you weren't here yesterday and you can do one right now, are you ready to do one? Or are you going to wait? All right, later, go. What's the next element? What? P? What's P? Phosphorus. Phosphorus, okay. So that has, every phosphorus atom has 15 electrons. Where are you going to park those 15 electrons? Go. So you put 2 of them in the 1s orbital. Yes. 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 3p what? Let's take a look. She says she ended at 3p3. I'm going to take a look. Here's the third energy level. 3s1, 3s2, 3p1, 3p2, 3p3. She should have ended at 3p3, and she did. All right. Delaney, you ready to go? Do one? You have to remember, you can do it. I don't care if you make a mistake. We'll find out something. 16. So number 16 is sulfur, right? All right, we're going to park 16 electrons. 3p what? 3. Okay, let's take a look. She says you should end at 3p3. All right, ready? Here's 3s1, 3s2, 3p1, 3p2, 3p3. I think you should end at 3p what? You should end at 3p what? No, let's take a look again. P1, P2, P3, P4. Okay, so you should have had 3p4, right? Is that right? Yes. I can't see you. Oh, move the camera. Sorry. May, you ready? Hey, Madison, can you do me a favor and close that door? It's a bit loud. Are you ready, May? What's element 17? All right, tell me where to park 17, wait a minute. You mean chlorine. Yeah, you say chlorine?
Yeah.
My fault.
1s2, 2s2, 2p6, 3s2.
Wow, you're fast.
3p5.
Now, is she in the right place? Does she end in the 5th column in the P block? All right, let's do a couple more and then we'll be done. All right, 18. Julie, you ready? Okay, what's the element 18?
Argon.
Oh, something special is going to happen because he's a noble gas, so go.
Okay, so 1s2, 2s2, 2p6,
2 or 3?
2, and then 3s2, and then would it just be 3p6?
3 what?
3p6.
Okay, now, look right here. Whenever you have 2 in the S and 6 in the P, I promise you're going to be a noble gas. And you're one of those elements that do not like to react. Your electrons are so stable that you don't want to gain or lose electrons. Let's go for another one. Was there another one? Look at that. Here it is. 2 in the S, 6 in the P. Noble gas. See that? All right. All right. And I'm running out of room here, so I'll do number 19 right here. And Madison, you do, what's on element 19? What is it? What's element 19? Potassium? Okay, where are you going to park 19 electrons? Wait, you're going too fast. 1s2, 2s2, what? Okay. Now, what's interesting, and this is where it gets complicated, okay? The third energy level actually has another kind of orbital. Yet, something weird, the periodic table tells me that you're not going to put it in the 3D. And I'll show you what 3D looks like in a minute here. The periodic table, Madison, where'd you say the last 2 electrons went? Or last electron went? It is, and if you look in the periodic table, it has to because it's the first element in the 4th period. It's in the S block, 4s1. Okay, and the last one. All right, Kyle, I'm sorry, Zach, you want to do this one? What's element number 20? What's that? Calcium. All right, go.
1s2, 2s2, 3p6.
Okay.
4s2.
What do you think? Okay, now, what I want you to do is, before you turn this in, I'm going to look at it again. Let's look at this whole thing again. This is called the electron configuration of the first 20 elements. Everybody with me? Now, these are all the electrons. If I were to ask you to circle the valence electrons, circle the valence electrons, it's the outermost energy level, not orbital, level. Now look right here. The outermost energy level for hydrogen is 1, level 1, isn't it? So how many valence electrons does he have? How many? Isn't that right? There it is right there, right? He has 1 valence electron. Now I want you to jump all the way down to lithium. How many valence electrons, how many of the 3 electrons are outermost energy level? Not this level, this one. So how many valence electrons do you have? Everybody in the room, come on. 1. Uh-oh, look for a pattern. I'm looking for patterns. Jump all the way down to sodium. Sodium has a total of 10 electrons, but how many of the 10 are outermost energy level? Oh, not neon. I mean sodium, sorry. How many valence electrons for sodium? Not level 2, not level 1. My outermost energy level is 3. So how many valence electrons? Uh-oh. Look what I just did here. Find hydrogen. Find lithium. Find sodium. And what do you see? Where are they at? Look right here. Everybody in this column is going to have how many valence electrons? 1. My valence electron is 1s1. My valence electron is 2s1, 3s1, 4s1, 5s1, 6s1, 7s1. You ever seen a pattern or not? Now go back and do the next one. Now, helium's very unusual, but it has 2 valence electrons, But because the first energy level can only hold 2, he's the only noble gas that doesn't have 8 valence electrons. Because he didn't have 8, he only has 2. So he's kind of an exception to the rule. That's why you see him see up there by himself a little bit. All right, find beryllium. How many valence electrons? I have 4 electrons. How many are valence? 2. Find magnesium. Find magnesium. How many valence electrons? Outermost? No. My outermost is 3. 2 valence electrons. Everybody get it? You see a pattern? Everybody in this column right here is going to have 2 valence electrons, and they're going to be in the s orbital. 2s2, 3s2, 4s2, 5s2, 6s2, 7s2. You know why they call it the s block then? Why does the s block only have 2 columns? Either you put 1 in the s or you put 2. Now, this is where it gets, I think you got this down. I think you probably got this, right? Now, today I gave you a sheet, and I need to show you, we'll go a little bit deeper in this, okay? A little bit deeper. And what they found out was in the, there you go. I have a small typo on this. I didn't notice it. It's not even typed. So it's a hando, okay? I have a small hando. This is supposed to be a 16. I don't know why I wrote 18. Okay, because 2 times 16 is 32. Now, if I can have your attention for about 5 more minutes, I think you can see the pattern here. We're going to teach longer, but in the first energy level, the only orbital that exists there is an s. And there's only 1 orbital. Each orbital can hold 2. You should only be able to put 2 electrons in the first energy level. That's why there are 2 elements there. Next. In the second, we have S and P. So how many kind of orbitals in number 1? Just S. How about 2? S and P. There's only 1 kind of S, but there's 3 kinds of P orbitals. See the pictures? Okay. Now, that's 4 orbitals. 4 times 2 is 8. I can put 8 electrons in the second energy level. I keep looking at your faces because I keep scanning, because I have to know if I'm losing you, okay? The third energy level is bigger. It can hold more electrons. It has an s orbital. It has a 3s orbital. It's also got 3 p orbitals. But then it has another kind of orbital, and it's called d. Now in the book, they show a picture like that, and it's so weird. I like the s orbital. It looks kind of like a ball. I kind of got used to the p orbital. It looks kind of like a dumbbell. But mathematically, they have figured out that there are these other orbitals, and you don't even see them till the third energy level. And look at it, look like weird. Don't they look weird? Look at that, you know? If I had twins and I want to save money, that'd be a double pacifier, wouldn't it? Okay, you know, it looks weird. It just looks weird. So, let's look at the sheet here one more time. This is not that hard now. You can get it. In the first energy level, there's only S. In the second energy level, there's S and P. In the third energy level, there's S, P, and D. There's S, P, and D orbitals. Now, how many kinds of S orbitals are there in any level? 1. How many kinds of P orbitals? 3. Watch, odd numbers. 1 kind of S, 3 kind of P, 5 kind of Ds. There's 5 D orbitals. And there's another one, I won't spend very much time with you. When you get to the 4th level, you have S orbitals, 3 P orbitals, 5 D orbitals, and 7 F orbitals. 1, 3, 5, 7. S, P, D, F, S, P, D, F, 1, 3, 5, 7. Now, I don't want to get too complicated with the F orbitals, but let me show you how this works. The third energy level can actually hold 18 electrons. But how many elements do you see in period 3? Look up there. Why do I only see 8? Why do I only see 8? You should be able to go like this. Put 2 in the S, and put 6 in the P, and put 10 in the D. 10. 5 orbitals times 2. I'm missing 10 electrons in period number 3. Now, I didn't do this, but God did this. And some humans figured out that where does the 19th electron go? It should go in 3D, but it's not there. The periodic table tells me that the 19th electron went where? It went way up in the 4th energy level, 4s1. Where's the 20th electron go? 4s2. Okay, but you know what? You still have never filled out the 3Ds yet. That's why we get to this part of the periodic table. Look right here. You see this part right here? All right, I have a name for that. This is called the D block. That means you're filling the D orbitals. All right, stay with me again. How many D orbitals? There's only one kind of S. There's 3 kinds of P's. There's 5 kinds of D's. Each orbital can hold 2. 5 times 2 is 10, right? How many elements are in the D block? This is neat. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There you go. That's why there are 10 elements right there where the transition elements are. That's why there's 10 there. Are you guys able to see this? Is it too early in the morning to see the beauty of this? And you know what this block down here is? You know what these are? You know what that is? It's not the S. They're not filling S orbitals. Here's the S block. You're not filling P orbitals. That's here. You're not filling D orbitals. That's right here. What is this right here? F block. And how many F orbitals are there? How many? Not 1, not 3, not 5, but 7 times 2 is 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oh, yes. Now you know why there are 14 elements down there, because they're filling the F orbitals. Your book doesn't even show the picture. I have another book that has pictures of F orbitals. They're even more weird. And I won't spend very much time with F orbitals with you guys. So, ready? Here's the last thing. See how hard it is. I'm going to read the periodic table. If you'll stay with me, okay? Stay with me and read the periodic table. 1s1, 1s2. What's this one? Everybody. 2s1, 2s2, 2p1, 2, 3, 4, 5, 6. Noble gas. Noble gas has 8 valence electrons. 2 of them here, 6 of them here. Go around the corner now. 3s1, 3s2, 3p1, 2, 3, 4, 5, noble gas, 6. I have 8 valence electrons, 6 of them are here, 2 of them are here. Now, watch what happens here. The 3rd energy level is not full. But instead of going to the 3rd energy level and filling it, it jumps and puts 2 of them in the 4th energy level. 4s1, 4s2. Now subtract the number. 4s1, 4s2. Subtract the number and say D. 3d1, 3d2, 3, 4, 5, 6, 7, 8, 9, 10. Now go back to the 4th energy level. 4p1, 4s, 4p, 3d. Let's go down here. 5s, 5s, 5s1, 5s2. Subtract the number. 4d. 1, 2, 3, 4, 5, 10. Go back to 5. 5p1. Do you see it? Is that a little bit too much for you? Okay. Anyway, so what I'm going to do is I'm going to show you just one more thing, and then we'll stop. Okay. This side of the handout sheet, tells you. Let's see. Do I have a new one? Let's see if I have a new one here. Here's a new one. Yeah, this hasn't been written on yet. Okay. And one more thing I'm going to teach you, and it's kind of fun, a little bit fun. There was a guy, one of the scientists in here, his name is Pauli, Pauli. And Pauli, they did some really fancy experiments showing that you can put 2 electrons in an orbital. That's fine. But I'm going to get a little bit into physics here, okay? Anything that has a charge. Did you know that electricity has a charge, a negative charge? You know that? Electrons have a charge, don't they? Anything that has a charge, if it moves, it will actually create a magnetic field around it. If I had a wire, and I did this early with Faraday, if you had a battery and a wire, and you let electricity go through the wire and through the battery, and you laid a little compass next to it, it would deflect the needle. Because the electricity going through the wire would create a magnetic field around it. That's pretty neat. But what electrons are moving, and they have a charge. So guess what's around every electron? A magnetic field. This guy named Pauli found out, he said, you can put two electrons in an orbital, but one of them better be spinning one way, and the up arrow simply means you're spinning one way, and the down arrow means you're spinning the other way. If they spin the same way, they'll kick each other out. And so this is called an orbital diagram. This is kind of fun. And what we're going to do is going to do some up arrows. So here's what we're going to do. There are two people involved. Pauli's exclusion principle says if you have two electrons in the same orbital, one of them has to spin one way, one has to spin the other. Now that's not that hard to remember, okay? And there's one more rule, and this was called Hund's rule. It said, and this only applies to p orbitals, d orbitals, and f orbitals. And again, I didn't win a Nobel Prize like this person did, or I don't know if he won a Nobel Prize, but he said when you're in a p orbital, you have to put one here, one there, and then you go back and pair them up. It's more stable to go clockwise, then come back and fill them in there. So let's go ahead and do the first 20 elements like this. Ready? Hydrogen. That's 1s1, right? This is actually kind of fun if you let it happen. Where's the next electron going? 1s2, but it has to spin the other way. How about the third electron? Where's it go? Look at the periodic table. Where's the third electron go? Look at the periodic table. Where does the third electron go? Everybody in your room. Everybody. What is it? All right, 2s1. All right, and we'll go ahead and let you spin that way, right? Where's the next electron go? This is 1s2, 2s1. Isn't that right? Where's the next electron go? Where's the fourth electron? Does that go 2s2? Look at the periodic table. 2s2. Okay. And this is the only thing that's different right here. 2p1. 2p1. Now, go over here. Put another up arrow there. 2p2. 2p3. Come back. 2p4. 2p5. 2p6. Now, what element is this? Anybody know what element this is? Aurora, do you know what element am I at right now? I'll give you a clue. Ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Element 10. Neon. And you know what's special about neon? It's a noble gas. And what did I tell you before? If you have 2 in the S and 6 in the P, you're going to be a noble gas, aren't you? Ah. What's next? Ready? Where's the next electron go? Look at the periodic table. Where's the 11th electron go? Look at it. Where's it go? Look at the periodic table. 3s1. Where's the next one go? 3s2. Next one? 3p1, 3p2, 3p3. Now what? Now I can go back and pair them up. 3p4. Remember, Hund's rule doesn't apply to S. S always goes up, down. Here it goes up, 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 down, down, down. What element is that right there? Delaney, what element are we at right now? Count them up. Okay, let's try it. 2, 4, 6, 8, 10, 12, 14, 16, 18. Who's number 18 on the periodic table?
So you wouldn't just count the row you were on?
Say it again.
So you would count all of them?
Yes.
Just count the row?
Yes. What element has 18 electrons? Yes. What's special about argon? Yes. And you know what all noble gases have in common? They have 2 in the S and what? 6 in the P. Ooh. What's the next element? You know where the next electron should go? It should go in a 3D. It should. But some people, really smart people, figured out The 19th electron didn't go there. Look at the periodic table. Where did the 19th electron go? It should have gone right here, 3D. Tell me, look at the periodic table. Where'd the 19th electron go? Somebody said it. What?
Potassium. K.
Where?
K.
Did it go 4s1? Didn't it not? Look at the periodic table. Isn't the 19th electron at 4s1? Where's the 20th electron? Isn't that right? Now watch, this is critical. This is crucial right here. You would think you'd go to here, wouldn't you? No, you haven't. You keep forgetting to fill into 3D. Okay, now I'll do it. How do I know that the 21st electron goes there? How do I know that? Where's it at? Where is the 21st element? What block is it in? Is it in the S block? Is it in the P block? What block's it in? The D block. And I'm the first element in the D block, so I'll put 1 there. And then 2, and then 3, and then 4, and then 5, and then 6, and then 7, and 8, and 9, and 10. What element am I at now? Help me out. What element am I at now? I'm getting kind of big now. Look in the periodic table. I just finished filling the 3 Ds. So look in the periodic table, tell me where I'm at. If you finish filling the 3 Ds, here's where you start filling the 3 Ds. Where do you end filling the 3 Ds? Go ahead. Say it again. Try here. Ready? 3D 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Isn't zinc? All right, get it? All right, so what we'll do, listen, go ahead and, did everybody finish this? I can give you a grade for that. Would you like, did anybody not finish it? Does anybody need to give it to me tomorrow? All right, will you put your name on that and put it on the back table? I'll give you a small grade for that, and I'll give it back to you tomorrow. Yes?
Could I turn it in tomorrow?
Yeah.
I love this episode.
Yeah. Listen, I couldn't tell. It seemed like part of the time you were really, really on it, and it's okay to get lost a little bit and then come back. If that's what happened to you, you're okay. You're okay? All right. Well, thank you.
This is the last that I could have.
Oh, okay. Okay. You know what this is? Okay. Can I help you on that one?
Yeah.
Because I helped people yesterday. Here, you know which one was a limiting reactant? Here's another mistake I'd like you to fix. That only has 1 sig fig. And remember when we were doing that chapter, you had to have at least 3 sig figs. So your number is going to be way off because you only have 1 sig fig. So if there's any way you could take that, divide it by the molar mass, and get 3 sig figs, that's going to help. So I want you to take it back and finish it.
Okay.
Same thing here. Change that to 3 sig figs here. Then you got to find who the limiting reactant is. It's going to be this guy.
Yeah.
He's the limiting reactant, so that's what's going to happen. Now, look right here. I brought this much peanut butter, but guess what? You only use that much of it. Whatever you get right there, that goes here. Put moles of Ki and change it to grams. It asks, how many grams of Ki reacted? Not how many did you bring. That's how many moles you brought, but how many actually reacted. See, if this is the limiting reactant, I brought this much peanut butter, but you didn't use all of it, did you? So after you change that to 3 sig figs, I think the picture will be better. So
Okay.
give me 3 sig figs. That's how much you brought Ki, but that's how much got used. So you take that number right there and just change it to grams. Change the moles to grams, and then you'll be able to do that one.
Okay.
Now, let's see here. You do have to show your work here. So can you show me, how do you get that number? You would say this. You'd say 5.43 minus 0.95. I should see some work here, okay? What's 3 say? That's no good. It says give a brief description of a double replacement reaction. Isn't it like this? Isn't it like A, B plus C, D? What happens?
Oh, yeah.
Okay. All right, there you go.
Thank you.
And if you talk to Layla, if she did the same thing with her lab, okay, thank you. Oh, your observations are on here. All right, do me a favor and stay, please. Can you stay, please? Because it's stay.
I didn't know if they had to do observations, so I just did them.
Yeah. Hey, Jonah, when you're making it, don't use a lot of that, because a lot of it, you can make a pretty concentrated solution with, just a little bit of it. Yeah, so I can see, getting a beaker, putting a little bit in there, put some I have the distilled water back here on the cart. And you can make a gob of it just with a little bit of that.
Like 5 grams?
How much?
5 grams of this?
That's a lot. 5 grams a lot. Yeah, I could even see 1 gram. I could just see taking a scoop of it and just get a little bit in there, put it in a beaker, a little water, stirring it up. That'll still be pretty concentrated.
Got it.
Hey, what are you doing here? Oh, for next class.
Class.
Okay. Oh yeah, that's right. Look at that. That's right. I keep forgetting.